Welcome to qnawire.
Okay, in this problem, we are asked to find the total translational energy of a bacterium. So we have to find total K of this bacterium, which has a total mass of 2 times 10 to the negative 15 kilograms at 37 degrees Celsius. And we assume that 70% of its mass is water, and then we have 30% other. We assume that its other mass is on the order of 10 to the 5 proton mass, U. So the formula we're going to use to find K is simply using kinetic theory. We can express that we have the total number of particles times the average energy per particle at a certain temperature, which is 3/2 kT. This is a result from kinetic theory, where K is Boltzmann's constant. We're going to use that. So the hard part of this problem is we need to find the total number of particles in this bacterium. That's really where most of our time is going to be spent. To do that, we can say that the total number of particles with molecules, rather, in this bacterium is the number of water molecules plus the number of other molecules. So we can say that if 70% of it is water, we can say that 0.7 times total mass we can do a conversion. 1 proton is just 1.66 times 10 to the negative 27 kilograms. And 1 molecule is simply, for water, is 18U. We can do this big conversion to give us the number of molecules. Oh, we also have to add in, that's just for the water. We also have to add in, for the rest of it, 0.3 times the mass of everything else. Also 2 times 10 to the negative 15 kilogram for its total mass. Convert, same conversion factor there, except in this case, 1 molecule is 10 to the 5U. Okay, and let's actually fill this in just to be clear. 1U is just the mass of a proton times 10 to the negative 27 kilograms. Okay, so we need to do this calculation. Once we do it, we are left with 4.69 times 10 to the 10 molecules total. Where all we've done is counted for the total water and the total other using their mass. And that gives us N. So that's the hard part. The easy part is now just using the result from kinetic theory. K is just N times 3/2 kT. We're given the temperature. It's just 32 degrees Celsius, I believe. We can just use our results now. 4.69 10 to the 10 molecules multiplied by 3/2, the Boltzmann constant, 1.38, 10 to the negative 23 joules per Kelvin. I'll leave the units off just to make things a little bit nicer. And in Kelvin, we have about 310 Kelvin for the temperature. And once this is calculated, we will end up with a total translational energy of 3 times 10 to the negative 10 joules. And that's it.